Hello everybody, welcome. This is paper 1 from November 2023, time zone 1. Let's work through this and see what we can do. Not a bad question to start off. I would say working through this exam, one thing that is a little more unusual compared to others is the structure. Usually the exams might go from the least challenging to most challenging by and large. This one has some quite challenging questions relatively early on, but I guess that's one of the reasons the 5-minute reading time might come in handy. Okay, let's start with question 2. The Great Pyramid of Giza is the oldest of the 7 wonders of the ancient world. When it was built 4,500 years ago, the measurements of the pyramid were in Royal Egyptian Cubits, REC. Viktor reads online that 1 rec, or 1 REC, is equal to 0.52 meters, rounded to 2 decimal places. Write down the upper and lower bounds of 1 REC in meters. So we have 1 REC is equivalent to 0.52, and this is rounded to 2 decimal places. So let's work through this and see what we have. So we have 1 REC is equal to, let's write that, 1 REC is equivalent to 0.52 meters, but it's rounded to 2 decimal places, so this value right here. And then if we ask ourselves the lower bound and upper bound, I'm going to write it right here. Lower bound, let's use a different color. The lower bound, what is the least possible value this could be if we are rounding to 2 decimal places? So again, we could have 0.51, and then what? If it's, let's say, 7, we round up. If it's 6, then we round up. And if it's 5, then we would round up. Anything below, if it's, let's say, 5149999, we're rounding down to 0.514. But since we're rounding up to 0.52, our lower bound in this case is going to be 0.515. That's the absolute lowest it could be. Anything lower we round down, and then of course anything higher we're rounding up. The upper bound, let's work this out with a similar kind of logic, so 0.52, and what could this be? If it's 4, for example, we're rounding down. If it's 5, you might say, okay, well if it's 5 we're rounding up, but let's extend this logic. If it's 4, we're rounding down. If it's 0.49, we're still rounding down. And we can extend these 99999 on into infinity. And then if we do, if it's 0.5249999 all the way to infinity, essentially what we have is 0.525. So anything at 0.5249999, or essentially 0.525 and less, we round down, and anything above 0.515 we round up. So write down the lower and upper bounds. Let's write this out in a way that they might like. Lower bound is equal to 0.515. Upper bound is equal to 0.525. You can write this as an inequality as well, as in x is greater than and less than, if you like. Alright. The Great Pyramid of Giza has a square base with side lengths of 440 REC and a height of 280 REC. Viktor assumes that these two measurements are exact and that the Great Pyramid can be modeled as a square-based pyramid with smooth faces. So they're telling us square-based pyramid, 280, that's our height, and side lengths, which is a square base, so all equal side lengths for our pyramid. Find the minimum possible value in cubic meters. So the minimum possible value, that tells us that we should be using our lower bound in this case. So if we have 1 REC is equal to 0.52, but potentially it could be actually a little lower since we're rounding. Let's use the lowest possible value to find out the absolute minimum volume of this pyramid. Okay. So let's go ahead and take a look. I'm hoping I have our formula booklet here, so we can just look at it together, I suppose. Here it is. Let's go ahead to geometry. This is actually the new standard level formula booklet, as opposed to the standard higher level. It's condensed, I suppose. Okay, so what are we looking for here? We are looking for the volume of a pyramid. Let's see. Volume of a prism. Volume of a right pyramid. There we are. Volume is equal to 1/3, or 1/3 area of the base, and then h is a height. So volume is equal to 1/3 AH, where A is the area of the base. Okay, let's write that down here. Volume is equal to 1/3 A, which is the area of the base, times height, the height of the pyramid. And we want to work with the minimum. So what do we have here? A few different ways that we can work this out. Let's try to simplify things as much as possible. Area of the base. Area of the base, if we're talking about some pyramid, or this, and let's not use that one. If we're talking about the pyramid, square base of 440 REC. So if we're talking about the side lengths, let's find the area of this base. Let's sketch it out. And not a bad idea to sketch if we have geometry, a geometry question. So this is equal to 440. But we know that it's 440 times 0.515, because this is the absolute minimum. So this is going to be one side length. Let's find the area of the base. 440 times 0.515. 440 times 0.515 is equal to 226.6. And I would recommend leaving your values like this instead of writing 22.7. Try to preserve all the accuracy that you can up until the final answer, where you would write in 3 sig figs. So intermediate steps, wouldn't recommend writing out in 3 sig figs. You'll have a little deviation in terms of level of accuracy. So if this is one of the side lengths right here, 22.6, the area of the base for a cone, sorry, what am I saying, for a cone, for a square, is going to be, well, side length 1 and let's say side length 2, which are equivalent. So let's go ahead and write out the area of the base. Volume is equal to 1/3, and then area is going to be 226.6, and then we can write this out as squared, but just for simplicity, 226.226. So that's the area of the base. And then we're asked, okay, what about the height? And the height, they tell us, is right here, 280. So if we've got some pyramid, I'm just going to draw something like this. Not going to go 3 dimensions, not exactly. But our height of our pyramid is equal to 280. But again, we want to use the lower bound of 0.515. Okay, 0.515 times 280 is going to be equal to 144.2. Let's keep all the accuracy as well, and let's write it out as 144.2. Okay, so it wasn't actually too bad, I suppose. And now let's just work it out on a calculator. So let's see, 226.6, square that value, times 1/3, times 144.2. Okay, quite a large value. Volume is equal to 246,106.051. Minimum possible value of the pyramid in cubic meters. If your calculator gave you this, they might write e to the 6. It would say plus e6 or something like that. It might be like 2.47 plus e to the 6, which is essentially saying 2.47 times 10 to the 6. Where this calculator notation is saying, okay, well, times 10 to the 6. And this would be absolutely fine for 3 sig figs. If we wanted to write it out in this very long form with all of our digits, to 3 sig figs, we would write this as 2, 4, 7. and then 0, 0, 0, 0 point. Actually, we don't need that last point. If we want to write it out using scientific notation, if this is our decimal place right here, 1, 2, 3, 4, 5, 6 hops. And then we would get 2.47 times 10 to the 6 hops, or times 10 to the 6. Essentially, we're multiplying by 10 to the power of 6. Alright, and that would be our minimum volume in meters cubed. Alright, so potentially some of those rounding questions can be difficult, but somewhat formulaic, I suppose, as well, once you've seen a few. I'd recommend converting your units. Converting your units initially, I think, simplifies the process. Alright, everybody. I hope that was helpful, and as always, best of luck. Take care.